In question number 6, this is a question to do. Welcome to this live. We are going to discuss this Jan paper of 2025. Number 6, this is a question to do. Welcome to this live. And we are going to discuss this question of a circle, whereby we are told the point A -1, 2 and the point B 11, 6 both lie on the circle with center P. The point M is the midpoint of AB, so which means we can be able to find the coordinate of M. But for part A, we are supposed to find the equation of L. So before we do anything, we need to work out the coordinate of M. How do you get the coordinate of M? For us to find the coordinate of M, we are going to find midpoint. Midpoint of AB. And for us to get the midpoint, of course, we shall take -1 plus 11 over 2, comma 2 plus 6 divided by 2. So that's going to give us the midpoint in that case, and that's going to be 5 and 4. 5 and 4. Now, we find the equation of L, and something that we need to remember, L is the perpendicular bisector of that. So which will mean we need to find the gradient of AB, and the gradient of AB, gradient of AB, which is going to be what? Change in y over change in x, so it will be 6 minus 2 over 11 minus 1. We shall say 6 minus 2 over 11 minus 1, and that is going to be equivalent to 4 over 12, which means that the final answer in that case is going to be 1 over 3. So since that gradient we have found is the gradient of AB, so the gradient of L is perpendicular, so it will be -3 at the gradient of L. Then we can now say y equals to mx plus c. Y is 4 is equals the gradient, which is -3. X is 5, then plus c. So which means 4 minus 4 is equals to -15 plus c, which implies that c is equals to 4 plus 15, which means this is going to be 20. Therefore, the equation of that perpendicular line is going to be y is equals to -3x plus 20 in the form y equals to mx plus c, in the form y equals to mx plus c. The next part is to, given that P has coordinate 7k, where is P? P is here. As coordinate 7k. So if you want to find the value of y, in that case we are going to use this coordinate we have here together with the equation of the straight line that we have obtained. We have obtained this equation of the straight line to be minus 3x plus 20. So if we want to know the value of k, because this is the y coordinate, we are going to say that is going to be minus 3 into 7 plus 20, and that is going to be minus 21 plus 20, which is going to be negative 1. Negative 1 is the correct answer for that. So that is for part B. So what I'll just do, I'll just copy this part that we have worked here so that I can be able to fix it down. Yeah, so I can take it down here, and I'm going to fix somewhere there, and I'm going to call that part C. Part C. Yeah. Let's look at this part B, rather. This part B. We need to look at part C. What does part C say? Find the equation of the circle. Now that we have the center and we have one of the points, the center is going to be center of the circle is going to be 7 minus 1, but we already know that one point, we have this point here, this is going to be the radius. So for us to find the radius r, we are going to say square root of 11 minus 7 plus 6 minus 1 squared, and this is going to be the square root of what? 7 minus, you need to use your calculator at this point of time. Use your calculator there. -11 - 7, that becomes 4, so 4 squared is 16 plus 7, that becomes 49. So we shall have 16 plus 49, and then this becomes root 65. That is the radius. Root 65 is the radius of this beautiful circle that we have at this point. So if we can transfer it down here so that we can be able to proceed, we shall say radius is that. Then the equation of the circle is going to be x minus 7 squared plus y plus minus of 1 becomes plus squared is equals to root 65 squared. Now that becomes the equation of the circle, which is x minus 7 squared plus y plus 1 squared is equals to 65. Yeah. Okay. So basically that's the concept that was tested for equation of a circle, and then we need to look at trapezium rule. We have trapezium rule with us here. How do you work out trapezium rule? So Roman 1, use the table below and using trapezium rule and all values of y given, show that the answer is that. So we know that area is going to be given by a half of the value. Huh? And out to me. And to me. Then that becomes h into y0 plus yn plus 2 into y1 plus y2 plus y3 all the way the final part. So in this case, our height, you can see from one to another we are having an increment of basically 1. So this is going to be equals to a half times 1, and our y0 is this, so we are going to have log 4 base 10 plus log 9 base 10 plus 2. Let's put here log 5 base 10 plus log 7 base 10. Of course, we shall have 6 base 10. Then we shall say plus a log 7 base 10 plus log 8 base 10, which is going to become a half into, this is going to translate what? This is going to translate to log, when these are added we can multiply the numbers, so it will be log 36 base 10 plus 2 into bracket. So this is going to be 5 times 6 times 7 times 8. What does it give you? 5 times 6 times 7 times 8. This is going to be 1680 log 1680 base 10. And if we square, if we raise this to the power of that, so we are going to have a half into bracket log 36 base 10 plus 16, that answer 1680 squared times 36, square root of the answer becomes, what does it become? Yeah, can you check what does it become when you work it out? You can write in the comment section, what does it become? You guys just comment in the comment section what the answer will become. Yes, I'm just waiting for your response, guys. Don't just keep quiet there. I can see you guys there. Just like the live and also comment below there what should be the answer become when we simplify that. waiting to see the first person to comment. Are we proceeding with that commenting? Just comment and let me know what should that simplify to. Of course, it's a huge number, yes. Nobody's commenting. Guys, I'm waiting for you to comment on that. Okay, that's, I can see Zion. Is that Zion or the Zion think is 4? Another person with a different opinion on that? Zion is saying the answer should be 4. Thank you for that comment, Zion. Yeah, so what we're going to have here is that if you multiply, or rather you raise this power, this number, you raise it to power 2, that is 1680. 1680 raised to power 2, that's going to be 400 log 400, a very huge number, yes. And then we multiply this number and this, then we find the square root. So this is going to be equals to log to the base of 10 of this number and this multiplied. Yeah, Raka, yeah, that's true. We're gonna write it, but I wanted you guys to be active, just so that I am not the one who's talking to myself here. Yeah, then we find the square root of that number because we are having this half, so we multiply this and this, we raise to power a half. Then if we simplify that, that's going to be like that, 80. Yeah, so that is exactly what we are going to get. Yeah, Zion, thank you for being here. Rakan, is it Rakan or Rakan? Okay, Rakan. And you guys, I wish you the best of luck in the paper of tomorrow. We've been here since the May-June exam started, and I wish you the best of luck. Oh, all right, anything's fine. That's great. All right, I'm glad you guys are here, and please share this live and also like and remember to subscribe to Proflan, because we shall be working together for P3. We shall be here, P4 will be here, and also for those guys of further pure math. The reason as to why we cannot simplify it fully beyond this level is because you can see they are telling us the reason as to why we cannot go and get the final answer. You guys, stop being you should not be nervous. If you really have done some past paper questions, don't be nervous. Just understanding how to approach different questions. So since the question was telling us to show that we have this, so it will mean we shall leave our answer in log form so that we can know what is k. K is basically this number that is here. Yeah, reckon we shall leave it here. We shall not put it in the calculator because we were supposed to find the value of k. Yeah, it's an integer to be found, right? Now, so let's move to Roman 2. We need to move to Roman 2, and Roman 2, find the value of a such that 2 log that. So let me write it so that I can be able to copy it down. 2 log 5 minus a base 5 minus log of a plus 25 base 5 is equals to 1. So what you need to understand is the basic laws of logarithm so that you can be able to solve a question that will be asked tomorrow. The paper of tomorrow, they're not going to ask you this question, but they'll ask you a question related so that you can be able to apply the knowledge. So let me just walk you through on how you will use the laws of logarithms here. Yeah, so I'm just saying that if you are feeling nervous, take it easy. This is not the first exam you've done many exams before, because if you become nervous, you'll even forget those things that you can, which are concepts which are very easy. Yeah, just take it easy, bros. Yeah, wish you the best, guys. So let's work out this. Now, with this, we have this 2 there, so we are going to take it up so that we are going to have log of 5 minus a squared base 5 minus log a plus 25 base 5 is equals to 1. Then once we have gotten that, we are going to combine this. So this become as a single log, that's becoming what? As a single log, what will it become? As a single log, we are going to have log 5 minus a squared over a plus 25 base 5 is equals to 1. Now, using index notation, we are going to say, if you are having in index notation, if you are having log b base a is equals to m, how can you write this? We can write this as b is equals to m raised, we can write this as a raised to power what? M, like that. So basically we are going to take this 5 raised to power 1 here, and then we do away with the log. So we are going to have in bracket 5 minus a squared over a plus 25 is equals to, in index notation, 5 raised to power 1, which is basically going to be 5. Zion, good. So which is going to be 5a squared is equals to, that's going to be 5a 125, right? 125. So which means that we can be able to expand this and open the bracket. So if we expand this, we're going to 5 squared is going to be 25. 5 times negative a times 2, that is going to give us negative 10a. The negative a squared is going to give us a squared is equals to 5a plus 125. And you can see these guys here, they are pushing us to have a quadratic equation. So if they are pushing us to have a quadratic equation, well and good, there's no problem. We shall write a squared. If we bring this 5 on the other side, we are going to have negative 15a, and then 125 comes this side, we are going to have minus 100 is equals to 0. So we are having a quadratic equation, which means we are going to simplify, or you can be able to use quadratic formula, or you can be able to factorize so that you can be able to get the solution to that. So if we solve that, we are going to have this simplifying to what? It will simplify to a minus 20, a minus 20, and a plus 5 is equals to 0. So we shall have two answers for a. A is going to be 20, or a is equals to minus 5. So anytime you have question to do with logarithm, so once you have gotten the answer, you need to come back to the equation, check. If you substitute a is negative 5, will the answer inside the log be positive? If you anytime you get a negative inside the log, then it means basically you are going to ignore a number, you are going to ignore a value. And also we have to check any condition that were given in the question, any condition that was given in the question. And you can see now, if we take a is equals to 20 and we input it here, it will be 5 minus 20, and we are going to get a negative. So that is going to be math error. So we are not going to take a equals to 20 as a solution. Yeah, you don't decide at this level that a is a negative, then you ignore that. No, you go back to the equation that you are given, you try to put those that value you have gotten in that expression. You check if that expression you have a negative when you put the answer you have gotten, then you are going to ignore that number. Especially now, if we put a is 20, it will be 5 minus 20, that will be negative 15. So we have to ignore that. Zion on point. I mean, that's great. You are on point. Right. We have another question, and in this case we are told that a student said that if x and y are irrational numbers, x not equal to y, then xy are also xy is also irrational. Show by counter example that statement is not always true. So we can be able to say there that probably tomorrow you'll be given proof by exhaustion or proof by counter examples. Yeah, so those are the possible part of questions that you can be able to be asked. So if we are talking of irrational numbers, and we want to just have an example that discredit that statement, and in this case, if we try, for instance, root 2 times root 8, what answer is it going to give us? Yeah, this is going to give us what? Is going to give us 4, because if basically if you take root 2 and you multiply 2 times 8, because if you're having two sides like this, you can be able to say it's 16, so 16 is 4, and this answer that we have gotten is not irrational. Prove using algebra that all odd integers prove using algebra that for all odd integers. Yes, the question that you're asking, prove by or show by count example, you just try to figure out if there is a number that is going to make the result not to be true. So that's just enough for that. Prove using algebra that for all odd integers n, the value of the expression is always even but never multiples of 4. So which means that we know that an odd number, how do we write an odd number? For instance, an odd number can be written as 2m plus 1. 2m plus 1. So we can be able to input that odd number into the expression that we have here. So we can say it will be 2m plus 1 cubed plus 3 into 2m plus 1 then plus 2. So we are going to expand whatever we have here so that we can see exactly what we're gonna get. If I'm having 2m, if I'm having 2m plus 1, if I cube that, this is the same as 2m plus 1, and I want to, if I want to have this, I'll say 2m plus 1 squared. So if I expand this part, I'm going to have 4m squared plus 4m plus 1. Then I will remember to multiply with 2m here plus 1. So 2m times 4m squared, that's going to give us 8m cubed. It's going to be 8m cubed. Then 2m times 4m, this is going to be plus 8m squared. Then 1 again 2m times 1, that will be plus 2m. Now I'll be multiplying 1 times 4m squared, that will be 4m squared. 1 times 4m to be plus 4m, then plus 1. Then now I'll put the like terms together. 8m cubed, 8m cubed at this point. I know you guys, you are faster multiplying than me, but bear with me. We have to 12m squared plus, yes, you are faster. I'm an old man. You guys, you are young. You do things very fast. Right, this is going to be 6m then plus 1. So once we have this, I can be able to, because the statement was, let's go back to the statement, prove using algebra that for all odd integers, that's why I came up with 2m plus 1. 2m plus 1 is an odd number. 2m is an even number. But if I say plus 1, now it becomes an odd number. So we are supposed to prove using algebra that for all odd integers n, the value of the expression, this is always even, but never a multiple of 4, but never a multiple of 4. So how are we going to do that? We are going to group these guys. Oh yes, which part is that? Which one? Yeah, let me just retract. I see which part was that the guy saying. We have 8m cubed plus 12m squared plus 6. Which value do we leave out? Yeah, you can just comment in the section. Which value do we leave out? Oh yes. Yeah, so this part that we have here is this particular expansion. This expansion that we were having at this point is this expansion that we were having here. Yeah, so once we have gotten that expansion, we need to add this term also and this term. We should include those two terms. So let me just write it. It will be 8m cubed plus 12m squared plus 6m. Now plus 6m, we are having also this time, this will give us plus again 6m, and we have 3 times 1, which will be 3 plus 2, which is going to be 5, then plus this one that we have in here, then we have finally 6 at that given point. So our final answer becomes 8m cubed plus 12m squared plus 12m plus 6. Yeah, so I need to take you back to whatever we were saying here. Prove using algebra that for all that odd integers, we use our odd integer to be that, and we had to input it in this part so that we expand, we see what we have, and the expression we get is this one. Okay, we are good to go. Then is always even, but never a multiple of 4. Never a multiple of 4. So if a number is a multiple of 4, it means it can be expressed as 4 times something. There is 4 times something, right? So let's check that is not true, right? So if you group this guy here, these guys and these guys, we can be able to factor 4 out, and then we can say this is 4 into 2m cubed plus 3m squared plus 3m plus 6. Because there will be a 4 inside here, so I'll say plus 1, so that I can say now plus what? 2. Because 4 times 1 will give us 4, plus 2 will give us this 6. So you can see this first part I have here is a multiple of what? Is a multiple of 4. But when you add something, that term stops. This is an even number. The all of these is an even number because you can be able to factor 2 out, and this can be in a multiple of 2, but it's not a multiple of 4 because we see this is 4. The first part of this is a multiple of 4, plus 2 spoils the plot. So that is exactly what we were supposed to show in that particular case. So we can say this expression we have here is even, but not multiple, of 4, but not a multiple of 4. Yes, if you've understood how to work out this question, guys, just write a comment understood, so that I can know that you have understood. But if you've not understood, I can be able to repeat that explanation. So if you've understood, write in the comment understood. If not, I will repeat explaining that. All right, so guys, Proplan also have as a Patreon page where you go to download these papers and this document I've worked here. Remember to join our Patreon page so that you can be able to download this solution that I'm working at this given point. Yeah, join the Patreon page so that you can be able to access the PDF and also this paper I'm working on. I'm going to upload immediately just after the live, and I wish you guys all the best in your coming exam. All right, question number 9 is a question from integration, and we have a curve whereby M looks like a stationary point. M looks like a stationary point, and there is a region R here. So let's see what the question expects us. The figure 3 shows the sketch of the curve with equation that using calculus find the coordinates of M. Using calculus find the coordinate of M. How do we use calculus to find the coordinate of M? And of course we say that M basically is a stationary point here. So how do we use calculus? And remember y is given by the equation 9x squared into 5 minus root 9x squared into 5 minus root x over 5. How do you go about that? Of course, you are going to simplify, and if we simplify this, we are going to get 9 over 5 x squared into 5 minus root x. I can open the bracket, and this is going to become 9x squared minus, this is the same as x raised to a half, so this is going to be a half plus 2 is going to give us 5 over 2, so this is going to translate to 9 over 5 x raised to power 5 over 2. So that is the function that we need to differentiate. So we shall do dy dx at that level, so that we can have, if you are differentiating, what are we going to get if you differentiate that expression? Good. Zion, we are together on that. I can see you have said we are going to use differentiation. Yeah, so basically that is the concept. We are going to apply differentiation, and at the stationary point we shall have dy dx is equals to 0. So which means if you differentiate this is going to be 18 minus, we take the power down, 5 over 2 times 9 over 5. What do we get? 5 over 2 times 9 over 5. This is going to be 9 over 2. And we shall have 5 over 2 minus 1. And the new power is going to be x raised to power 3 over 2. So this expression that we have, we are going to equate it to 0 so that we can be able to find the coordinate of m. So that was part A. We're using calculus, part A, using calculus there. So we can be able to say this is our part A. So this is our dy dx. Yeah, ensure tomorrow whenever you are doing those questions, be very careful you don't make mistakes when you are doing the subtraction, and whenever you are doing the differentiation, because if you make a mistake, you see it's going to cost you a lot. We try to minimize mistakes as much as possible. Yeah. So now taking whatever we have here at the stationary point, dy dx is equal to 0 at the stationary point. So we shall say 18 minus 9 over 2 x power 3 over 2 is equal to 0. So we can be able to say it's 18 is equal to 9 over 2 x 3 over 2. Then we can try to make x raised to power 3 over 2 the subject, and that is going to be 18 times 2 over 9. And we can say x is raised to power 3 over 2 is going to be equivalent to 4. So that our x is going to be 4 raised to power 2 over 3. And if we put that in the calculator, what does it give us? 4 raised to power 2 over 3 is going to give us what? What is it going to give us? Oh, yeah, so this was 18, sorry. This was 18, where is it? This will be 18, yes, this will be 18 here. I think I'm messing there. This is 18. This is 18x, 18x, yeah, that's true. 18x, so I have to remove this part. I think I'm writing quite fast and making a mistake on that. Yeah, so if I divide by x, I divide by x, I divide by x at this point, I can see this and this will cancel out, and we end up having 18 minus 9 over 2 x raised to a half. Yeah, so that is going to be 0, so which is going to be x raised to a half is going to be 4, right? Is going to be 4. Then for us to work it out, we shall now square this and we shall square that, so that our x is going to be 16 at that given point. So the value of x at m is going to be 16. It's good that we were able to identify that so that we can be able to proceed. Then for us to find the y coordinate, we are going to substitute with the value we have gotten. Our y coordinate is going to be equals to, we shall substitute the x value, so it will be 9 into 16 squared into 5 minus root 16, because our x was 16. Then we divide by 5. If you work it out, you will get a value which is around 460.8. 460.8 at that point. So we can say the coordinate m, our coordinate m is going to be 16, 460.8 as the answer for the coordinate of m that we were having here. Yeah, so this is the coordinate. We are done with that. The next part, which means now if we have this coordinate as 16, 460.8, it means this line here is the line y is equals to 460.8. That's the equation of this line here. Yeah, and if we want to know what could be the equation of this line here, we are going to take the function of the curve and equate it to 0, because it's going to cut the x-axis at a given point. So we shall take this equation here and equate to 0. So we shall say, let me just write it so that we can be able to work it out. If we want to know what the value of p is, because let's see, using algebra, find the coordinate of p. To find the coordinate of p, because this is the x-axis, then we're going to take this equation, we equate it to 0, and we shall have 9x squared into 5 minus root x over 5, we equate to 0. And you can see if we multiply 5 both sides, we are going to have 0. Divide by 9, we shall have 0. So we can have x squared into 5 minus root x is equals to 0. That's what the equation will simplify to. So we can say this part is equals to 0, or this part here is equals to 0. So we can say x squared is equals to 0. If you find square root of 0, it's basically x is equals to 0. And that is why we have this line passing through 0. So x is equals to 0 is for this part here. The other part, we are going to say 5 minus root x is equals to 0. We shall take root x on the other side. We shall have x is equals to root x is equals to 5. Then we square both sides. If you square both sides here, we are going to have x is equals to 25. So which means that this coordinate here is 25, 0. This coordinate is 25, 0, because this is the x-axis, y is 0. So basically that's what you are supposed to do in that particular question. And if you are learning something here, don't forget to like and also recommend ProfLearn channel to your friends to help ProfLearn to grow the channel. So the coordinate for B is going to be 25, 0. That's the coordinate. So what does that mean? That means this equation here is going to be y, sorry, not y but x is equals to 25. So we are supposed to find the value of what? Using algebraic integration, find the area of R. So which means we know from this shape that we have here, the only thing I need to do is I need to find the area of this area, the area of this part I'm shading here. I need to find the area of this part I'm shading. And how will you find it? I'm going to integrate the curve, the graph that I have, or the curve that I have, and my integration will be from 16, the limit of integration from 16 all the way to this point, which is 25. So for I to get the area under that graph, I'm going to integrate from 16 to 25, the curve that I was having, 9x power 2 into 5 minus root x over 5 with respect to x. If I do that integration, it's going to give me the area of this green part that I've identified at that given point, right? So let's do that integration, because already I've said now that is part C. I'm going to integrate from 16 all the way to 25. And what is the expression that I'm going to integrate? The simplified expression basically that I'm going to integrate is this expression that I simplified here, 9x squared minus 9 over 5 x raised to power 5 over 2. I believe I can copy it so that it's faster for us to have it. Let me just copy it so that I can just write it. I can just have it here. Let me just paste it here. Oh, good. Yeah, so we have the expression that we are going to integrate, and we are integrating that with respect to x. How do you integrate? We are going to increase the power by 2 and divide it, so we shall have 9x power 3 over 3 minus 5. So I want to get the new power, 5 over 2 plus 1. I get the answer. The answer I'm getting, I will divide it by 9 over 5. So 9 over 5 divided by the answer I got, I'm going to get 18 over 35 x raised to power what? 7 over 2. Now we know that for integration we need to include the constant, but since we have the limits, I'm not going to include the constant. So we shall have 16 here and we shall have 25 at that given point. So if we substitute so that we can be able to get the area, shall say 9 over 3 into 25 raised to power 3 minus 18 over 35 into 25 power 7 over 2. I work out that, and then I will subtract the result when I substitute 16. So it will be 9 over 3 into 16 cubed minus 18 over 35 into 16 raised to power 7 over 2. So if we work it out, can you check the answer you'll get? Yeah, so this is also can be simply as 3. Okay, no problem, but we already worked it out. So the answer you get is 1312.7. 1312.7 as the area of the green part that we have here. So in order, this area that we have here is 1312.7, this one here, this one. Then we need to find the area of the rectangle, the whole of this rectangle. You can be able to find the area, so that it will be 25 minus 16 times 60, 460.8. 25 minus 16 is 9, so it will be 9 times 460.8, and the answer becomes 4147.2. So R, area of R is going to be equals to 4147 minus 0.2 rather, minus 1312.7. So if you work it out, you are going to get your answer as 2834.5. Yep, can you comment if that is okay? So we shall get our answer like that, and our answer is supposed to be given to correct one decimal place, and exactly that's what we have left it to, correct to one decimal place. So that's what we are supposed to do. Yeah, so we have question number 10. Question 10, you guys. Question number 10. This is the last question we are going to do. Yeah, this question is a very good question. And please guys, allow me to do it on the board. Allow me to do it on the board, and I believe that will be much fine. Yeah, because writing that question indeed it's a bit long, but just allow me to do it in the board. You guys, have you allowed me to do it on the board? Question 10. Yes, now we are moving to question 10. Question number 10. Yeah, so for question number 10, I'm going to do it on the board so that we can be able to, you guys, follow through. We are very sure that definitely that question will appear on trigonometry. Question will appear. Let me just do it on the board. Yeah, so I'm trying to fix the camera for the board so that we can be able to work out that question. And the reason as to why I've decided to do that, the question is long and it's better if I have enough space whereby I can be able to work out the question. And I believe it's clear on the other end. You can be able to see the board clearly. All right, so the question says, guys, confirm if the board is clear so that as we proceed, we are supposed to show that for question 10 trigonometry, question 10, I have to ensure that I have a nice pen that can be able to, you can be able to see when I'm writing. So we are looking at question number 10. And in question 10, we are supposed to show that cos theta into bracket 3 tan theta plus 2 over tan theta is equals to sin theta plus 2 over sin theta. So basically we are supposed to show that if we are having the left hand side, we can be able to rewrite in this particular format. How are we going to go about this? So something that we need to remember is that we can we shall use left hand side to show the right hand side. So we are going to use the left hand side to show the right hand side. So which means we can write this as cos theta into bracket 3 sin theta over cos theta, because tan theta can be written as sin theta over cos theta. And then we shall say plus 2 cos theta over sin theta. So because this is 2 over tan, so I have to find the reciprocal to that. And if I multiply, you can see if I multiply this guy and the first term, cosine will cancel out, and then we're going to have 3 sin theta there. If I multiply this guy and this guy, I'm going to have plus 2 cos squared theta over sin theta at that point. So how am I going to simplify this? I don't know you guys whether you can hear me, you can be able to follow through, and just write in the comment section that you can be able to hear and you can be able to follow through. And I wish you guys good luck, all the best for your coming exams. I wish you all the best in your coming exams. Yeah. And this is actually the last question. It's clear. All right, Zion, I can see you are responding. It's clear. Of course, you can do it about guys. I'm glad that you are here, and I really wish you the best. So, moving to the question. So this is going to reduce to what? This is going to be 3 sin theta plus. How can I write cos squared theta? I can be able to, because you see, whatever we want to show on the right hand side, it doesn't have cosine anywhere. It doesn't have cos anywhere. So which means that we can comfortably change this cos squared theta to sine. And what is that what can it be expressed as? So we can be able to say this is basically 2 into 1 minus sine squared theta over sine theta, isn't it? So which means that as we proceed with this expression, we are going to have 2 sine theta plus 2 minus 2 sine squared theta. Oh, is it going to become this? Is it going to become that? Let's see whether it will. And then we shall have sine theta here. And of course, here is like we are having 1 at this given point. Then meaning we can be able to express it as a single fraction sine theta there. So 1 goes to sine theta times. So if we multiply that sine theta here, we shall have 2 sine squared theta, then plus sine theta goes to sine theta 1, so everything that we're having is multiplied by 1, so we shall remain with the same thing, minus 2 sine squared theta at that given point. We are almost home and dry with this, and which means that at this given point, the next question is the most important part, which you need to understand how to go about it. This one, most of you know how to work it out. The next part is the most important part. As we're going to finish this live, we're going to see easy steps you're going to do in order to solve trigonometry questions. So if you take this guy and this guy, what are we going to have? If you take this guy and you combine with this guy, what are we going to have? Is it matching up? Yes. Shall have 2 sine squared theta minus that to cancel out. Where did we mess it? Again. Where? Do we mess it again? Oh, yes. We see, this was what? This is 3 here. This is 3. Yeah, we write it properly, 3, and this is our 3 at this point. Yeah, so you can see any slight mistake, it's going to put you off the hook, and then you are going to be crying after the exam. So if you are going to say 3 sine squared theta minus this, we are going to have sine squared theta plus 2 over sine theta. So if you are having this, means this expression here can be divided for this term and the second term, then we shall have sine squared theta over sine theta plus 2 over sine theta. So which means that with this expression we have, this will cancel with 1 of that, so we shall have sine theta plus 2 over sine theta there. So we have shown that this part can be written in this format. That's exactly what you are supposed to show. That's how you are supposed to go about it. So once we've worked it up to that level, we need to go and now see what the next question was supposed to be looking like. Hence solve for x greater than 0 less than 2 pi. Hence solve, this is what we are solving, for x greater than 0 less than 2 pi. Right, so I need to refill this. So that we can be able to have our marker right properly. I need to refill this. Yeah, so refilling this. Yes, I'll take a short 2 seconds. 2 seconds. We are done. 2 seconds. We are done. Yeah, we are done. Refilling will not take us century. Done. Now, once we are done with this expression in part B, this is what we are supposed to do. Let me make use of this space. So because we've worked it out, let me just make use of this space so that we can be able to have enough space where we can be able to work out part B. So part B, we are supposed to solve between x greater than 0 less than 2 pi, and the expression we are solving is cos x into 3 tan x plus 2 over tan x is equals to 4 sin x minus 5. That is what we are actually trying to solve here, to giving your answer to 3 significant figures. So our answer should be 3 SF. Don't forget that. And this is basically in radians, so we ensure that we give our answer correct to the number of significant figures that you've been told. So once you've identified that, remember this expression that we are told here, this one that we are given, is exactly what we were given and we have shown there. So which means whatever we have on the left hand side here, we can be able to replace it with this part of the equation. So we shall say sine theta. Now our expression is not theta, it's x, theta x. So we shall say sine x plus 2 over sine x is equals to 4 sine x minus 5. We can now decide to multiply all through by sine x, so that we are going to have sine squared x plus 2 is equals to 4 sine squared x minus 5 sine x at that given point. So once we have this, what next are we going to do? We are going to put the like terms together. So I'll take this sine on that side and I'll take these two on the other side. So we end up having 4 sine squared x minus sine squared x will be 3 sine squared x, and then minus 5 sine x minus basically 2, and it's going to be equals to 0. So we end up having a quadratic equation. So with this quadratic equation that we have, we are going to say maybe let sine x be equal to m. We are going to form a quadratic equation which we are going to solve. So we are going to say 3m squared minus 5m minus 2 is equals to 0. So at this given point, I'll expect you to write in the comment section. Yeah, you write in the comment section how do you solve, what's the answer when you solve that quadratic. Yeah, when you solve that quadratic, 3m squared minus 5m minus 2 is equals to 0. If you solve it, what does it give you? If you solve it, which answers do you get? Yeah, so what I'll do, I'll just put in the calculator direct so that I can find m is equals to, I'll put in the calculator. Of course, I know your calculators have that functionality whereby you put the polynomial direct of order 2 in this case. So a is 3 minus 5 and then minus 2. My first value is 2, m is 2, or m is equal to negative a third. Now, if we are saying that m is 2, it means we are saying sine x is 2. How? That cannot be true, because the range for sine is 1, the maximum value is 1. So this one is not going to work out. We are going to ignore this value that we're having here. We shall say therefore that sine x is equal to negative a third. That's the only part that we are going to take in this case. Now, in order to use this value that we have gotten, we need to know where sign is negative, because sine x is negative a third. So which means we are going to draw the cast diagram, and the cast diagram that says that all students in the whole world, they trust Cambridge University. So in the first quadrant, all the trigonometric sine, cosine, and tangent are positive. In the second quadrant, only sine is positive. So we want where sine is negative. Sine is going to be negative in the fourth quadrant and in the third quadrant. So this sign that you get here enables you to decide where you are going to take which quadrant you are going to use. So anytime you have solved the quadratic and you have gotten these values, you are going to check, is it positive or negative? So if it's a positive, you use this quadrant and this, and if it's sine. But if we are saying sine is negative, is in the fourth quadrant and the third quadrant. So once you've gotten that, we are good to go. You have identified that. Then now you are going to say sine x is equals to, and of course this is 0, and this is actually what? Pi. And when of course you go round, you are going to have what? 2 pi at this given point. After going a full cycle, 360 is somewhere there. So once you've done that, now you are going to say this is 1/3. Then we are going to say x is equal to sine inverse of negative 1/3, so that we get the principal angle. And this is going to be x is equals to what? If we put in your calculator, and ensuring that your calculator is in radians, ensure it's radian up here, we are going to say sine inverse of negative 1/3, and if I put that, I get my answer here. Are you seeing that? That? Yes. So my answer is going to translate to negative 0.340. Three significant figures. So it means if it's negative angle, what does that mean? You see here, we are supposed to find positive angles. But when I find the sine inverse, I'm getting a negative angle. What does that mean? It means the angle I've found is the angle below there. That's what it's telling me. This negative is the angle below. But if it was positive, that angle could have been above here, above this x-axis. So if it's a negative, you read the angles clockwise. So which means that at this given point, this angle that we have here is basically 0.340. You are not going to write negative. You are going to write positive 0.340. Why? Already it's below the x-axis. That's why it's a negative here. So also this angle that we are having here, is, because of symmetry, is the same value that we are having on the other side. So we shall have 0.34. I don't know whether you can see that. 0.340. Yeah, ensure that when you are going to write your answers tomorrow, you are writing good handwriting. 40. So the range of the angles asked is from 0 all the way to 2 pi, and we know that positive angles are usually measured in clockwise. So the first angle we are going to take is from this point moving all the way to this level here. Positive angles are measured anti-clockwise. So the first angle will be from here, you move all the way to this point that we have here. So that's going to be pi plus 0.340. So we are going to say pi plus 0.340. If you add that, those two angles, you are going to get 3.48. So our x is going to be, the first angle is going to be 3.48 radians. 3.48 radians. Yeah, 3.48 radians. So this angle here is 3.48. How did we get it? You read from here, you move all the way to this point, isn't it? The second angle is you are moving from here, you move all the way anti-clockwise until you reach here, because we are measuring positive angles. We are finding positive angles, 0 to 3 pi. So meaning that this one here, it will be just like 2 pi 360 minus this part that we have here. Or you can say basically 2 pi minus 0.340 is going to be 5.94 or 5.94 radians. So those are the angles we were supposed to give. Those were the angles we were supposed to get at that given point. Unless there is any question, yeah, we have our angles well stipulated here. These are the two angles we are supposed to work at this given point. You guys, good luck and have all the best for the paper of tomorrow. I really wish you the best. Stay confident. Whenever you're going to answer those questions in that exam, ensure you follow the instructions. If you are told to significant figures, please do that. Ensure that you are reading the question carefully, so that you can be able to pass that exam. Ensure you know the range is given in radians or it's given in what? In degrees. Good luck and all the best. You can be able to join our Patreon page. Also share this video to your friends. Encourage them also to subscribe, joining Proflan. Good luck and see you later. See you guys. All the best. Continue revising. Mine is done. That's what I had in store for you guys today. See you if you are taking physics. See you later for physics tutorials. Good luck.